thank you very much, everybody, for coming. Well, first of all, I'd like to thank to CREAF for inviting me, because I know more of you because of your publication, but I have never had the opportunity to meet you personally. So I think today we have the chance to discuss, to talk about our experiences, our research in terms of a particular ecosystem that is planted pine forest. When Mauricio asked me to come here, I suggested to work in this specific ecosystem because I think it's quite important in terms, at least in Andalusia, the place I work on, because it's one of the ecosystems that we don't pay too much attention. And there is a lot of information about other type of natural or semi-natural ecosystem, but not in artificial ecosystem. And I think the impact of climate change is quite important on this type of ecosystem. But before starting with my presentation, I'd like to introduce very briefly about myself in order to say that my background is forest engineering. It means that for me, science is important to have a good tools to support silvicultural decision. But finally, I need to do something on the field. And sometimes that's, again, a discussion about scientists and people working on the field. But our school is a school of forestry, so we need to offer to the forest department some alternative to implement on the field. So we always look for the balance between science and practical application of scientific knowledge. And I think that's quite important. So we work mainly in tools to be applied in terms of silvicultural, like dendrochronology, ecophysiology, remote sensing data, and so on. So we look for the tools to develop a new silviculture. It means that our research group is more oriented to this type of tools or capacity to look for any kind of adaptive silviculture. And for us it's important not to think about the future of forests, but the current situation of forests. What we can do now, right now, in order to adapt forests for the future. Sometimes we work a lot in terms of models, prediction models, what happened in the next 20 years, 30 years. No, that's not our situation. Our situation is that we need some kind of action today. Once, after this brief introduction, I divided my presentation in 4 main parts. The first is try to introduce the concept of a pine planted forest under climatic risk. What means this concept? Then I'm going to show you some situation we have right now in Andalusia related to mortality processes. You are going to see that it's an impact, it's very high impact today. So we have to face the problem right now, as I said before, and then I'm going to give you some results in terms of silvicultural adaptation tools to adapt those forests to the new situation. And finally, some ideas about the new silviculture I think we have to work on. In terms of introduction, I think all of us, we agree that the climate change is creating a new situation in terms of forest ecosystems. Why? Well, because we can expect a change in terms of climatic condition, and those change could be non-linear, so could be erratic. We don't know about the climate in the future. We are not sure about the climate in the future. We also have a lot of new perturbation, or the impact of perturbation at different scale. We have seen the last weeks, for instance, the problems with forest fires in California, but we have a lot of problems about pests and disease, health problems in terms of forests. There is a new impact in this situation. We have changes in terms of chemical cycles, like carbon, nutrients, and always also change in terms of biodiversity. So the consequences of this could be loss of biodiversity, but in particular for us, we have to work in mortality and decline processes, because it's one of the impacts that we have already in Andalusia. And what happened in terms of prediction? If we look at the prediction in terms of situation in South Spain, we can see that the prediction by the meteorological agency in Spain that this area in the eastern part of Andalusia is going to be drier, much drier. And what happened? That we have more of the planted forests on this area, like Sierra Nevada, Sierra de Filabres, Sierra de Baza. More of the pine planted forests are located in the eastern part of Andalusia. So there is a coincidence between the areas more affected because of climate change with the area where those planted or plantations are located. So we can expect a higher impact on this area because of the climate change. What happened right now? Well, we already have those problems. You can see here in the western part of Andalusia, maybe more of you know about the seca problem, that is a problem related to root rot mortality, Phytophthora cinnamomi and other oomycete. And well, we have large areas of holm oak, cork oak already died completely because of root rot. We have problems with cork oak in Parque Natural de los Alcornocales, and we have many problems related to other pests like diplodia or other type of inadequate management practices. And in the eastern part of Andalusia, you can find from semi-natural forests, for instance, in Sierra de Cazorla, we have many changes in terms of structural and species composition, but we have problems with natural forests like Pinsapo fir. We have a multicausal mortality process related to Cryphallus numidicus, Dioristria, and drought. So we have all of these mix of mortality processes already in Andalusia. On this slide, you can see the landscape of those processes. You can see here, that is the Pinsapo fir area, and you can see many trees, they are already died. You can see here, that's the Sierra de Mágina, this is black pine, Pinus nigra forest, and they are also affected. You can see here this area in Parque Los Alcornocales with large areas, slope completely died, and that's the situation we had in 2013 in Sierra de Baza, where more than 4,000 hectares died completely just in one summer. So that's what the problem we are dealing with. And in particular, when we talk about pine plantation, probably more of you know this kind of this type of forests. They are very simple in terms of structure, in terms of age. They are more or less coetaneous forests. This is the area we work habitually, that is Sierra de los Vilagres. It's a mountain, typical Mediterranean mountain area. And you can see here a gradient of pine species from the lower part, that is Aleppo pine, to the upper part, that is Scott pine, Pinus sylvestris. And you can see how just the color change from the lower part to the upper part, from the Pinus Aleppo pine that is more or less adapted to the new climatic situation, to the Scott pine in the upper part. You can see this change to brown. So it means we have problems of mortality, problems of decline. So, and that's the concept we talk when we say that it's a pine plantation under climatic risks. And I think it's not a question of Andalusia, it's more than a question of Andalusia. If we look at a time scale, we can see that the problem started in 2001. Forest Department detected some damage in the area, but not very important. In 2006, the damage spread to other areas with more than 3,000, 4,000, 5,000 hectares with any different levels of affectation. And in 2010, we needed to take some palliative action. And that is important because if you look at the time scale, we didn't have enough time to develop scientific knowledge. We need to look for a kind of consensus between scientists and foresters in order to make application and take action in terms of silviculture. And finally, the situation right now, 2013, 2019, the problem have spread to other areas like Sierra Nevada, Sierra de Maria, etc. So what we expect for the next future is to have more and more problems, more and more surface affected for this forest decline processes, and so we have to try to look for this kind of new silviculture more adapted to this situation. So more and more frequently we are going to see this kind of landscapes that in the slide. in other areas, not only in Sierra Los Filabres, in Almeria, that is located in Almeria, but also in Granada, in Jaén, in other areas. But it's the same problem in other areas of the Eastern Iberian Peninsula. You can see the problems in Murcia, where more than 100,000 hectares of Aleppo pine are already affected because of this problem. We have problems in Alicante, Valencia, the same problem in Italy, in France, in Morocco. So I think it's a problem for all the Mediterranean basin. It's a problem related, obviously, to the planted forest. Once we have the concept of pine plantation and the climatic risk, I like to discuss with you the process we use to approach this problem. So we divided our work in three main steps. First, the diagnosis. Second, the cartography. And third, the silviculture. So I think that's a kind of framework to work on this problem. At least that's the framework we have to work on this problem. In terms of diagnosis, we need to know the causes behind the problem. And that's an important question I'm going to discuss later on in terms of what we need as forester to take a decision. We need to know the causes, but how much information we need to take decision. That's important. The first approach we did was by using the dendrochronological data, and we worked with 4 species in the area, that is Aleppo pine, maritime pine, black pine, and Scott pine. And what we saw that we can look for 2 different trends. If you look at the dendrochronological data, you can see the drought here in vertical lines. And what happened in general? After a drought, more or less, there is a capacity to respond to drought. So you see in black line, you can see the areas affected by decline processes, and at the upper part, in white, you can see the areas not affected by declining processes. So what we have seen that the areas not affected, they are able to respond to drought. Areas affected by those processes are not able to recuperate after drought. So we have 2 different trends. That's the trend of areas not affected, and that's the trend of the areas affected. So there is a decline of growth that is not possible to recuperate for. And that's the problem of the final mortality of those areas. And we compare natural forests with planted forests. Again, what we have seen? Well, we have seen that natural forests are much better adapted to climate change. Okay, that's good. But what happened after several droughts? Well, in this figure, you can see that's the drought in 1995. And you can see the lines are separated. Natural forests are able to respond to drought. But artificial or planted forests are not able to respond to drought. But after the drought of 2005, both types of forests lost the capacity to respond to drought. So natural forests are also losing the capacity to adapt to the new climatic situation. I think that's very important, because it's not just only a problem of planted forests. It's also a problem of natural, semi-natural forests. At this slide, you can see the impact of different environmental and silvicultural drivers in these mortality processes. In this figure, you can see that's Pinus nigra and this Pinus sylvestris. And if you look at this part of the figure, you can see that in the case of Pinus sylvestris, Scott pine, the main environmental drivers were climatic drivers. So Scott pine seems to respond to the climate. But Pinus nigra already respond to climate, but silvicultural drivers are also important. So it means that black pine, it could be adapted by the use of silviculture. In the case of Scotch pine, it's not clear that silviculture is able to stop or to adapt forests to climate change. And I think it's, again, we want to talk about this problem when we talk about silviculture, okay? Well, that's the question I talked you before. How much information we need to develop silvicultural tool? Well, we don't have information about ecophysiology processes. We don't know what there is behind of those mortality processes. We don't know. We are not ecophysiologists. We don't work in ecophysiology. And I propose you to discuss if we need the physiology. I think we need the physiology to understand this process. But in terms of silviculture, we don't need too much physiology. I mean, I think in general, we agree that the problem in terms of physiology behind the impact of drought are related to the hydraulic processes or metabolic processes. Okay, that's good information, and probably we need this information to increase our knowledge about mortality processes. But in terms of silvicultural application, I think it's not so important to have this information. Okay? Why? Because really, if the impact is in terms of growth, I don't have too much tools to be applied to make correction of this problem. So I think that's a discussion, and I am open to discuss with you if this is real or not real. But I think we need to look at balance between physiology and silvicultural action. Okay? And I think that's an important question to discuss. The situation right now, again, we have three main areas affected by mortality processes. One is this area, that is Sierra Nevada, and we have problem with phytoplants. Pinus is a bacteria, and is related to drought, obviously. We have another area that is Sierra de Baza, maritime pine with drought and with mastococcus, pests, so the relationship always between climate and pests. And finally, we have the area of Sierra Los Filabres, where only we have the problem related to drought. And again, you can see the landscape of those damage in the study areas. Well, once we have the diagnosis, we need cartography. And I think that's quite important. Why? I always say to my students that as a silviculturist, we need to know the territory. We need to express, in terms of spatial distribution, the problem we have. We need to use maps, because we are not working at the plot level. We are working at the landscape level. So we need to transfer the physiological or the plot information we have, for instance, by dendrochronological data, to the territory. If we don't make this transformation from the data to the cartography, we are not able to make action. Okay? And how to do that? Well, I think remote sensing data is the much better tool to project the information we have on the field to the landscape. So we have been working in the last 10 years with different sensors and with different spatial and spectral resolution. So we have worked with Landsat, obviously, but we have also worked with Hyperion, that is a hyperspectral sensor. We have working with Beer, that is a high spatial resolution sensor. So we have different sensors, and we have different information. We have different spectral information that we can make relationship with different ecophysiological variables, like pigments, leaf area index, hydric restriction, stomal conductance. So we try to look the relationship between physiology and remote sensing data to project this situation to the area. On this slide, you can see a comparison between 4 different sensors. Here you have a CREAF proba, that is a hyperspectral sensor. Here you have the Hyperion, is also an hyperspectral sensor. Here you have a Landsat, and here you have a INTA sensor, AHS sensor. The question here is not the difference between sensors. The question here is the remote sensing data is able to give us a viable information of the situation, and you can see here that the pattern of damage are quite similar, independent of the sensor we use. So we have now the capacity to project the information to all the area that we have. We are talking more than 10,000 hectares of planted forest. So we need to project the information. This is a leaf area index in cartography from the area we work. But if we need more detail, we even can work at the tree level. We can work at the stand level. You can see again the pattern of damage from green to brown. So we can work and we can project the information at this stand level. But even if you look at here, you can see the trees, the individual trees, we can detect the level of damage of each tree. So we can make a scaling up from tree to stand to landscape by using this information. But one important question is that we need to detect the problem before we have damage. And that's another question, because it's quite easy to detect this problem if you have damage already. But what happened before damage? So we work in the previsual cartography. And previsual cartography is to predict damage before you have damage on the field. This is a thermal information. It's a cartography of the same area. This is the conductance response of the trees related to the delta T. That is the difference between canopy temperature and atmospheric temperature. And when you change to red, means more sensibility to damage. When you change to green, means less sensibility to damage. So we can project the future, the close future, in terms of sensibility to this kind of decline processes. A different approach is by using radiative transfer model, and I think that's the future in terms of remote sensing data. And that's a projection of pigments, chlorophyll and carotenes. We work in the cartography at the tree level, as you can see here, at the tree level of pigment cartography. So that's a very, very powerful tool to predict the response of those forests, because they are more sensible to the damage. So in this paper, we established this kind of relationship between carotenes and remote sensing data. But you have another different approach, that is temporal series of data. For instance, by using Google Earth engine, you know this database. Well, this is the cartography of, this is Sierra Nevada National Park, and this is Sierra de Baza Natural Park. And we have been working with the Forest Department in order to develop a prediction cartography to phytoplasm sensibility. So what we did was to look to the pattern of the temporal series of a vegetation index and try to look if there is a different response on 3 different levels. That is the area not affected, that is the area sensible, and this is the area already affected. So we were able to inverse the model and to make a cartography to predict the sensibility. And that's also very important, because in terms of silvicultural programmation of activities, we need to look if we are going to put all our money and resources in the areas that could be affected in the close future, or we work already in the areas already affected. And that's an important question when you don't have too much budget to make a silvicultural action. Another different approach is by using unmanaged aerial vehicles, drones. Well, with this drone, you have the capacity again to work at the tree level. That's a segmentation of the imaging. And obviously, if you are working, for instance, with a pest, like Mastococcus, that is a pest related at the individual tree, then you need to look for a higher spatial resolution information. So by using this kind of vehicle, obviously you have the capacity to increase a lot your capacity to get good data in terms of spectral information, in terms of physiological information, and so on. One, we have the cartography by using any of the different tools we have already developed. then we need to look for the silvicultural action or activities. And well, that's one of the situations we have. I showed you before this slide. It was more than 4,000 hectares affected by mortality in 2013, and the Forest Department asked us what to do. Well, the question is very simple. What to do? We have this problem. What scientists think that is the best solution to this problem? And well, the answer is not easy, because we don't have too many tools, really. If we look at the bibliography, in terms of action, we have action related to resistance, to resilience, to transition. I think it is a good theoretical approach. But in terms of action on the field, what means this? What means transition or resilience? For me, it's not very clear. The only tool we have is thinning. In terms of action, in the short term, is thinning. And there's a review by Sohn et al. In 2016 about the impact or effect of thinning to adapt forests to climate change. So we concentrated our work in this problem. Thinning is a good alternative to adapt our forests to climate change. And well, here, the hypothesis is that yes, it could be a good alternative. So we decided to establish on the field different plots, experimental plots related to thinning with different intensities. And what we have seen, well, again, I think it's very important. That's the same dendrochronological data in these plots with different, for the two species, black pine and Scott pine, with the droughts here, and this line is the line where when we establish the plot and thinned these areas. Well, as you can see on the slide, the response of the areas affected was more or less similar. There was not a very good response in terms of growth, but the area that was thinned, the response was quite good. Okay, but if you look here, that is water use efficiency in terms of growth, what we have seen. Look at here, that's black pine, Pinus nigra. Before thinning, plots were, the response of plots were more or less similar. After thinning, we are able to see that the response is separated. So it seems that the response after thinning is constant on time. But what happened with Pinus sylvestris? After thinning, there is a convergence of a thinning plot. It means that in the short term or middle term, even the plot which were thinning were going to die. And that's an important question, because what to do? Even when we know that some areas are not adapted to the new climatic situation, we need to make silvicultural action. It's better just to leave the area and to forget the area in terms of silvicultural action. Well, the curious is that we used it in 2006, we used Gotilwa. Just to try, we didn't publish the results, but by using Gotilwa, we see that the effect of thinning was not perdurable on time, was not permanent on time. So sometimes what we are going to find is a loss of capacity to react to the thinning action. So in 2009, we started to cut down forests. And that's what we did. And you can see some of the areas we decided to make a thinning program with a high intensity thinning more than 50% of the basal area. So it means we are going to remove half of the forest to try to adapt the forest to this new situation. And you can see here some of the area like this one in maritime pine were cut down completely, or on this area like this one, or on this area like this one. The question is this decision supported by our result? We had the information to do that. Just to finish this part, I consider that to answer the question before, in terms of physiology, I consider that the answer for me is we need physiology data. But we need different kind of physiological data. In particular, we need continuous physiological data. We need more precise information about the response, the tree response. So now we are working with this kind of sensor in order to improve our knowledge of what happened in terms of physiology. This year was approved by the minister silvicultural network, that is Silviculture, where there are different research groups along Spain working with this kind of data, and we are going to try to put in common the information about the adaptation, different type of forests to climate change. In order to finish my presentation, I like to give you some ideas about the, in my opinion, the future of silviculture in terms of mortality, in terms of climatic change adaptation. I think we need to change the methods of inventory. The traditional methods of inventory are not able to get the information we need to establish a new silviculture. And I think we need to integrate remote sensing data in all the inventory, forest inventory. It means multispectral, hyperspectral, LiDAR, whatever you have, but we need to improve our capacity to get data from the field. I think we need a different kind of silviculture, more flexible. If you have background in terms of forestry, I have my background in terms of forestry, but for me, sometimes silviculture is too rigid. There is no space to take decisions. So we need some way to open silviculture to new action. And I think that's a question that is a problem for the people we have a forest background. Sometimes we are very close to accept that we need to take different decisions. I think we need to orient silviculture to other ecosystem services, like water in the south of Spain, obviously, to carbon, and we need to incorporate in the silviculture those concepts. Biodiversity, and that's a problem we work in terms of artificial forests. It's not easy to increase biodiversity on those types of forests. I think we also need a specific cartography. We need to develop tools to get a much better cartography of those processes. If we keep working at the plot level, I think this information is not enough to take a decision. So we need to project the information to the territory. And so again, we need to improve our capacity to use remote sensing data. I think we need to concentrate in forest regeneration, but it doesn't mean the main species. Sometimes what we are going to see is that we have what we call the last stage of tree vegetation. Some of these areas will be in the close future areas without trees. You have seen on the slide. And we need to accept that. I think we need more complex structure, forest structure. Those areas that you have seen on the slide with thousands and thousands of hectares with the same species, with the same age, with the same structure, forest structure, are not able to adapt to the new climate conditions. So we need to more complex structure in terms of vertical structure, but also in terms of horizontal structure. I think we need obviously diversification. That's not easy. It's quite easy to say that we need more biodiversity in our forests, but in planted forests in the south, I promise you that it's not easy. It's easy to say, but it's not easy to get. And finally, I think we need to concentrate part of our work in terms of forest health. Why? Because we have new pests, new diseases, we have new problems in terms of the impact of those pests on the field, like phytoplants. Phytoplants was present in Andalusia for a long time. Mastococcus is an endemic pest in Andalusia. Why now we have problem with this pest? Cryphallus numidicus was present in Pinsapo fir a long time ago. Why now is a problem? Heterobasidium annosus was present in Pinsapo fir long time ago. Why now is a problem? So we need to integrate health, forest health in the silviculture. Just in order to finish, I think the impact of climate change is already present in forest ecosystem in Andalusia. So we are not talking about future. And I think it's the same, more or less the same in other areas. I think we have a high vulnerability of our forests. We are in the front of climate change, clearly. I'm talking about Andalusia. We are in the front. We are a good laboratory for climate change, unfortunately. I think we need real-time information, so we can wait 5 years, 10 years, 15 years. We need information right now to take decision. And we also need to take silvicultural action in the next 5 years. So that's the question I told you before. We need a balance between science and action. Probably more of you are working, or some of you are working in your PhD. Probably you are thinking in terms of 5 years, 10 years. For us, it's too much time. So we need to integrate information to get data from the national inventory of whatever to try to find any kind of alternatives in the short term. We hope to get that because we need it. So thank you for your attention.
Many times immediately topic also the push to think about not just production of knowledge, but also integrating the knowledge with the management of the forests. So I'd like to ask if there is any questions for the world, please.
Thank you for the nice talk. You talked about the silvadapt monitoring network.
Yep.
You presented like SEP flow data and also dendrometer data maybe, or which data are
Well, this network is created by different research groups, so I understand that each group has different data. In our case, it's SAP flow and the dendrometer, and also we have some spectral information. This data logger have a spectral sensor to detect canopy, something like leaf area index, and to relate this information with remote sensing data, because in our case the objective is to make a relationship between ecophysiological data and remote sensing data.
And this was is focused on Spain, right? Is there any plans to integrate with other initiatives like?
At this moment, not.
Okay.
But I know, for instance, no, but this kind of sensor has been developed by Riccardo Valentini. He's a professor in Italy. And I know he's trying to spread this kind of sensor to other Mediterranean areas. Yeah, in fact, we have
there's two efforts at the moment. I think one is that one, and the other one is from Belgium, where Cathy Steffen is doing research.
Well, we decided this sensor because it was economic and also because easy to use.
It's the same principle. Yeah. It's like monitoring trees.
Yeah.
With dendrometers and stuff at the same time.
Yeah.
So it would be nice to integrate efforts because we need.
Yes, and also, for instance, we have been talking with Mauricio. We need any kind of comparison, contracts because if I'm working in Andalusia in the same area, that is this area, Sierra de los Filabres, our data are more or less similar. There is not too much information behind this data. So what happened if we compare this information with another plot in Valencia or in Catalonia or even in Italy or Morocco? So I think we increase our capacity to interpret this information.
No, and certainly if the methodologies are a bit aligned before starting, because then it's much easier later on to have proper comparison.
Rafa, if one question on the detail, when you look at this series of dendrochronology, do you get the impression from your data that what matters in terms of the decline of the trees in the declining areas has to do more with their chronic response to progressive changes in temperature, etc., or is it more like the acute response after the very strong droughts? What is the thing matters more? I think
it's more clear the second idea. I think, yes, the consecutive drought, the impact is higher than the increase of temperature. In my opinion, the increase of temperature obviously is going to impact forests, but it's more progressive. The problem is when you have 3, 4, 5 droughts consecutive, the capacity of trees to recuperate is very low. And now we have another drought. And the last one was in 2013. So that's the question about natural forests and planted forests. Probably for natural forests, the change in temperature could be acceptable. But now after so many droughts, this type of forests are behaving in the same way like planted forests. So I think the impact is more related to this kind of extreme climatic events.
Can you extend a bit on this loss of effectivity of the thinning treatments on a Scott pine? How long does it take to lose the effectivity? And if you have any suggestion on what's going on?
Well, it was established in 2009, and we published the work in this year, I think so, in 2019. So it was more or less, I think it was 8 years after thinning.
8 years?
Yeah.
And how intense was the thinning?
It was 30% of basal area and 50%.
So it didn't recover?
It didn't recover. It recovered after thinning, but the difference is between black pine and Scott pine. Both species recover after thinning. The short-term response was good. But in the long term, or in the short term, I mean, after 8 years, Scott pine seems that it's not able to recuperate in the long term. So again, we have the same problem with decline, growth decline.
But was it because the basal area was already, had the same value than before thinning after 7 years? No, because there is not because the capacity to recuperate growth is not, so the basal area is more or less the same. And there is no new trees on the plot. So I think the problem is the water is related to drought. I think also it's a question of species adaptation. Scott pine in the Mediterranean mountain areas like Sierra Nevada, Sierra de Baza, Sierra de los Filabres is not the best species to be adapted because it's more Atlantic or high mountains species. So it's normal that the capacity to react to the thinning is more limited. That should be also the first year. So why?
Why? Well, because obviously I think after open forests, the capacity to access to new resources is higher. But maybe after 5, 6, 8 years, again, the problem with carbon depletion, the problem with water use, the problem with physiological processes, again produce the same problem of forest decline. So I think it's a kind of rapid reaction to thinning and again to decline. Rapid reaction to thinning and again decline.
I think that's a problem with Scott pine, not with black pine.
One question I had was with regards to the remote sensing. You showed that you were able to use some spectral indices to detect areas that were declining, and they seem to be quite different in the response to the ones that were still healthy. And I was wondering, this idea of predicting areas in advance of the damage. So what are we talking about? Are you talking about a prediction in advance of 3 months or 6 months? You're talking about a prediction in advance of years?
Years.
So, no, not in theory, in practice.
In practice.
Do you think you can detect damage in advance of it occurring for how long? A year before?
I think years. I mean, even by using the dendrochronological data, you can anticipate damage because there is a reduction of growth. For instance, Camarero, another author, they have published a lot of work by using the dendrochronological data as prediction of damage. In terms of remote sensing, I think the advantage is that you can use different approach, that is using physiological data, like pigments. For instance, carotenes, I think it's a good prediction of damage. Not chlorophyll. Chlorophyll not, because the reaction is a little bit different. But carotenes, it could be. Water, stomachatal conductant, it could be by using thermal information. So we have several physiological information which are able to predict several years before damage.
So in other words,
I don't know if it's 4, 5, 6, but several years.
If you take the time series of these indices and you go back 3 or 4 or 5 years, you can already see that there is a spectral signature a few years in advance that is differentiates the different zones.
We think that is possible. Yeah.
So you have that, like the PowerPoint slide that showed this model that are using Lancet time series. And can we go back to that one?
Oh, sorry.
Oh, that one.
Well, we use a Google Earth engine. We take the temporal series from, I think, 1990 to 2017, I think so. And we look for this pattern. There are many publications that they use the pattern of temporal series to detect damage and to predict damage.
So do you have the name of the model of this?
Well, it was developed by us. But I can send you the publication. Yeah. But there are many publications by using temporal series of Lancet data.
Lancet, the Trender, that one?
Sorry?
Trender. The name of the model, like
I don't remember. But also you can use BFAS. BFAS is another model, temporal model. There are several models by using temporal data.
Just a quick question, is there another tree instead of Scots pine that can be planted that would be more resistant?
No, I don't think that's one of the questions we discussed with Forest Department and other scientists. I don't think the alternative is to plant new trees, new species. I don't think that's not possible. It's not economical possible. It's not technical possible. So I think that's not the alternative. The alternative probably is to accept that we are going to have a different forest landscape. Why to plant black pine, Aleppo pine? Who's going to pay that? We are talking about thousands of hectares. That's the problem I tried to show you before. It's not a question of scientists. That's a question of forester workers on the field. If you have 10 hectares, that's okay. You can plant again. Like a forest fire, small forest fire, okay, we can make a restoration project. But if we are talking about 4,000 hectares, is it realistic to say that we're going to plant another species? I don't think so.
So you showed that there was at least temporarily evidence that the natural, inverted commas, forest, they seem to have a better response to some of the droughts compared. So what is exactly that differentiates the natural forest from the planted one? Is it, because in other words, that should give us some indication about how to proceed. You know?
It could be genetic, because we don't know, many times we don't know the genetic of the planted forest. It could be selected from other areas in Spain, so we don't know the procedence of these seeds. That's a problem. Also, the structure is more complex in terms of vertical and species composition. I think even the site condition, because natural forests are located in good sites, but planted forests are located in any kind of site, because foresters, when we established those plantations in the 60s or 70s, they established anywhere. For instance, that's what happened with Pinus pinaster. Pinus pinaster in South Spain is related to calcareous soils. But those plantations are established in silicious soils, acid soil.
So you're saying that they actually planted those pines where there are no trees?
There were no trees.
Oh, so no native species?
No, no trees. Sometimes it was agricultural land or areas like without any kind of vegetation. I think it was a good decision. We are not to discuss now about if reforestation, afforestation, plantation in the 60s or 70s was good or not. For me, that's not important. The situation, we have more than 200,000 hectares, of pine plantation in Andalusia. And we need to manage those. We can say, okay, it's not my problem, or these forests are not very valuable, because they are, like people say that this is crop forest. Crop forest? Artificial forest? We don't need those forests? I think we need those forests. So we cannot say that it's not a problem because it's not natural.
Yeah.
I'm not sure I understand the implication, because so you say we have to accept that we'll have a different forest, but at the same time you say, but we're not going to plant new species because it's not economical. So does it need that but at the same time you say we need to keep managing?
Yeah, sure. Why? Well, I think, for instance, that's the question of prediction. If we wait to have the forest died, there is no answer to the problem. If we make the action now, we can change the structure. We can reduce density. We can change the spatial distribution of trees. We can make more complex forests. We can use natural regeneration of other species, like in Sierra Nevada National Park, that we have a lot of natural regeneration of Quercus. We can change Pinsapo fir and use Quercus faginia, natural regeneration. We can integrate shrubs like Arbutus medum. So if we start working now, we have the capacity to adapt forest. If we wait these mortality processes are already produced, then there is no alternative.
So if you say that we need to let natural regeneration,
then in some areas we have
we let the forest adapt themselves.
Yeah, but we have to remove part of the pine plantation. We need to make thinning.
Okay. Let space for the forest.
Yes, and to promote natural regeneration. We have to open some areas, and we have to try to accept those other areas with different densities. We need to incorporate these smart forest landscapes, more adapted to, for instance, to pests. What happened with phytoplants? If we reduce density, the vector of phytoplants is a beetle. So if we manage forests to reduce the capacity of the beetle to move from different stands, maybe we can reduce the impact of phytoplants. So we have many things to do, but before mortality. When you have mortality, just to cut down.
But what you say all goes towards more natural forest.
Yeah, but we don't have too much old growth, at least in Andalusia.
But so the following question is, if that's the way silviculture should go, do you think forest managers are open to that?
Yeah, sure.
Yeah.
I think they are open to that. Yes. They are open to that because they have seen the problem. It's obvious. You have, maybe it's a question of academy, it's a question of universities. Okay, maybe they say, but that's not very important. But now it's their problem. So yes, they are open to accept new ideas.
But for example, if the idea is to let Quercus ilex grow, but the economic return of the crop set is the same as Pinus silvestris.
Yeah, but that's a different problem. I think we need to separate. Well, it's an important problem, but I think we need to develop technological alternatives. When we have those alternatives, then we need to discuss if the forest department is able or not to pay those alternatives. I mean, it's not a question if you have a thinning plan, for instance, it's not very expensive, because even could be out of financial, you know? Yes, in Andalusia, sure. Yes, there is no problem. But we need the administrative mechanisms to put this on the field. So, in my opinion, foresters at the forest department, they are open to new alternatives. We need to talk with them. We need to work with them. The question about the capacity to implement those alternatives in terms of money, in terms of budget, in terms of administrative problem, is a different problem for me. Because I am not a bureaucrat. So I need to work in terms of new alternative, silvicultural alternative, know how to pay this alternative. To be realistic, yes, it's a question, important question, but not in terms of administrative problem.
Okay, very good. If there are no more questions, yeah, go ahead.
I wonder how far do we know that climate change is the sole factor that drives the forest decline? It could be that some forests, some Pinus silvestris are planted in already dry areas, and even more now we don't have silvicultural practices. That explains that many of these forests are declining because of that.
Yes, well, I think finally it's a mix of different situations, of different drivers. But in our opinion, climate change is the most important driver of decline in South Spain. I mean, I don't know in other areas, but in South Spain, climate is the most important driver. But, as you have seen on the slide, finally, we have other problems, like pests. So always we find the same relationship. First, we have some kind of decline. Then we have a pest, we have a disease, and then the combination of both produce the final mortality. But in terms of, for instance, fertility, soil fertility, it could be important, but it's not so important. Other environmental drivers, I don't think so. I think there's a mix between silvicultural condition, climate change, and some kind of relationship with pests and diseases. Always we find more or less the same scheme.
Okay. Many thanks for this last question. Very good. Many thanks, Rafael.